Now, how are we going to find out the maximum and minimum values that a particular data type can store? So to be able to do that, we need to include one important file. It's already included in my program. So it is the limits.h header file. I mean, the limits header file. That is what we're supposed to include. Now, this is going to contain constants that are predefined constants that are going to help us, know the maximum and minimum values that a particular data type can store. So basically we get our classic include statement. So pound include limits.h. So just so you guys don't forget what we are talking about. So we have to include that limits.h. So if we want to find out the maximum value that an int can store, so we have to grab our most precious printf function, and then we need at least 2 arguments. So we are going to say the size is, maybe the value is, now I'm going to be a little bit okay, we can avoid being lazy here. So we can say the minimum int to store, the minimum int to store is, remember we have to throw in our conversion specification, so that is going to be our %d, and then we need to throw in our new line so that we get a better formatted outputs. And then what are we going to throw in? What constant are we going to throw in? It is going to be int mean. So Visual Studio helps us there. So we save our program, and remember, just to be on the safer side, we try to use C99 again. So compile our program, boom, no errors, and then we try to run it. So we get that the minimum that you can store, the minimum integer that you can store is this number here. If you want to get the maximum, so we have to change here and say maximum, for example. We have to say maximum like so. And then the constant that we're supposed to use, I know you guys guessed it, it is going to be int max. Int max. Of course, little help from Visual Studio. Help is always a good thing. So we clear, or just so you see these things side by side, I'm not going to clear my terminal. I'm just going to compile. Boom, again, no errors, everything worked out perfectly. And then we try to run our program, and of course we get the largest value that you can store in the int data type. So basically this is going to be the largest data type that you're going to store in this int data type. Now let's look at the long, for example, and the long data types. How do you go about that? So first of all, one thing that we have to change is the conversion specification. If we want to talk about the long, for example, we have to say LD instead of D. So we have to say LD. If you just put D there, you're going to get something that is going to be incorrect. So we have to throw in there LD. And the constant that we're supposed to throw in, maybe you guys guessed it, try to guess. So it is going to be long max, for example, because we want to find out the maximum that the long data type is going to hold. So we're going to clear our terminal window because it got plotted. So we use C99 once more, and then boom, the maximum that we can store is that particular number. How about the minimum? So for the minimum, we have to change here, remember, so that we have correct things printed out on the screen. So we have to say minimum, and what constant are we supposed to throw in? I know you guys already guessed the constant, so it is going to be mean here, right? So if we save this particular program, we save our program, everything looks good. Visual Studio is not complaining, and I'm happy about that. C99 once more, everything works out perfectly. We print out our output to the screen. So that is going to be the minimum long that you can store. So if you want to talk about a long, we have to, for the conversion specification that we're supposed to use is going to be LLD, meaning long integer value, right? So here we're supposed to use, maybe you guys guessed it, so it is going to be LL long mean to print the minimum that this particular data type is going to hold, right? So we clear our console. Again, we use C99, and boom, and we print out our result. So we get the minimum that we can store. It is going to be this enormous, gigantic number here, right? And then if we want to get the maximum, we have to use another constant, so that is going to be int max. So all this is working because we've included the limits the limits header file. Minus including that file, nothing is is going to work. The constants are not going to be recognized. So we have to always make sure that we include the correct header file. So we print out, so that is the maximum value that you can store in a long. So we can see that as we move from our int to our long, we can store bigger and bigger numbers or integer values, right? Now this is a good thing. Now let's talk about a float for one moment. So for a float, the constants are not contained in the demystify.h header file. The constants that we're going to use. So let me just get rid of this so that you guys have the correct, can see things correctly and interpret things correctly. So the constants that we're going to use are going to be from the what? Are going to be from the from the float.h file, right? So this is the file that we are supposed to include. So let's talk about the minimum. Let's talk about the maximum double that we can store. The maximum double, for example, that we can store. The maximum double to store. Let's talk about the maximum double to store is, so here the conversion specification has to be, well, does it have to be percentage %d or no? Because it's a float, no, d does not work. No, you might think of using an f, but well, no, that is not going to work very well. So we throw in our e. So we say percentage %e, so exponential form. So we throw in our percentage %e, and then the constant that we are going to use is going to be dbl max, for example, dbl max, and then we're going to save our lovely program, and then I'm going to clear my console so that everything looks good, and then we compile our program. So remember the constant is dbl max, and then we have no errors, and then boom. So this is going to be, and the number is going to be written in, we have many ways of writing numbers. So this is a very, very big number, and writing it in this exponential form is going to be extremely, extremely important, right? So hopefully you guys, get the concept. Hopefully you guys get the concept, right? Now, I'll leave you guys, experiment a little bit with these constants. Try to find out the constants that you can use to print out the minimum value a character variable can print out. That is going to be your homework. Now, if you guys are still having problems and all that, I can still do that for you, probably in a separate video. But now we want to make progress, and hopefully you get what we're trying to talk about. So you always have to make sure that you are in the correct range, and always make sure that you use the correct data type. Now your choice is mostly going to depend on the if the value that you want to store can be stored as a long int, as an int, or maybe as a character variable. What is going to help you choose what to use? What to use is going to be the needs of your application. So if you want to use less space and all that, you basically have all those options for you. So a character variable is basically going to take up 8 bits of space. Generally, it is going to depend on the compiler and the platform. It might be different. And then the int is going to take up 4 bytes. The float generally 4 bytes. The double generally 8 or 6 bytes. Depends on the compiler once more. And the floats are single precision data types, and then the doubles are going to be double precision data types. So always have that in mind. Now, another thing that is very useful, something that we can also talk about, is that you can also convert between different data types. So for example, you can convert an integer into a double, and a double into an integer, a character into an integer. What we must keep in mind is that what we must have in mind is that the types have to be compatible. For example, I want to be able to convert between the data types when I have a number, for example. So it is easy like that. So if you have a string of characters and you want to convert it into an integer, well, that doesn't send a good signal logically, and then you're going to have problems. So the data types have to be compatible. Another thing that we must worry about is the size. So for example, if you want to convert a double into an integer, for example, those decimal places are going to be what? The number, we know that the integer values are not going to have any decimal places, so the number is going to be truncated. Part of it is going to be removed. So you might have memory loss there. So you might lose information there. You might have data loss there. So that is also something that you have to keep in mind. Another thing is that with signed variables, you can store both positive and negative numbers as well as 0. And for unsigned data types, you can only store positive numbers and 0. So whenever you're converting between unsigned and signed, you also have to be careful, because if you overflow again, you're going to get unexpected behavior, and things are just going to break. Now let's look at we have two types of conversions that C is going to do. So the first one is going to be implicit conversion. So this is going to be done by C without you doing anything. Now for us to be able to understand implicit conversion between types, let me give you guys an example. Let's say we have two numbers and we want to divide these two numbers. Let's say we have int number 1, then we set this equal to 4, and then of course we have to terminate our line with a semicolon, otherwise Visual Studio is not going to be happy and the C compiler is going to complain later on. So we have int number 2 is going to be equal to, let's say, 5. Now we want to declare a variable known as result that is going to store the quotient of number 1 and number 1 divided by number 2. So we can say int result, for example, and then we can set it equal to, or we can just declare it for now. We'll provide a value to it later. So that is also possible. I'm giving you guys a lot of possibilities here so that you guys get everything, so that you guys do not miss anything. So I'm giving you a lot of possibilities here. So result is going to hold the quotient of number 1 divided by what? Divided by number 2. Or result is going to be equal to what? Result is going to be equal to, or let's try to divide. Let's now provide the value. So we want results to store the quotient of number 1 and number 2. So we're going to say, or to divide. Of course, we've not yet talked about operators. We're going to do that in a few seconds. But to divide, you're supposed to use that /. Then you're going to say number 2, like so. Wow, let's now print out our result to the console. So we're going to get our most beautiful, well, we know that the division between the quotient of 4 and 5 is not an integer. So it is going to make sense that that this result is of type float. Again, always know the correct data type to use. If I declare that as an int, I'm going to have problems. My answer is going to be truncated. A part of it is going to be taken away. I'm not going to have the correct answer. It's because I know that division is going to produce, is going to produce a real number. And the real number is a what? Is a float. So always have that in mind. So result is going to hold the quotient. So now we get our printf. Let's now try to print out our float to the screen. Again, we need at least 2 arguments, so we can be a little bit descriptive and say the result is, and then we throw in our conversion specification that is going to be %f, like so, and then we throw in our result. Now, what do you think is going to be the answer? Well, if you do this, if you perform this calculation on your calculator, well, 4 divided by 5 is going to be 0.8. Now let's see whether we're going to get that 0.8 here. Let's see whether we're going to get that 0.8 here. We clear our terminal, we compile with C99, everything looks good, and then we print out our result to the console. Look at what we have. So the result is 0.0000. But what exactly is happening here? Why are we not getting our 0.8? Because 0.8 is the correct value. So whenever you are using division, you always have to be very careful. So what C has done here, C has done an implicit type of conversion. Remember, what type is number 1? Well, number 1 is of type int. And what type is number 2? Number 2 is of type int as well. So this operation, this division operation that we are performing here is going to be between 2 integer types. So the result of integer division is always an integer. The result of integer division is always an integer. So 4 divided by 5, so we're going to have 0 here. We're going to have 0. This is going to be the result, 0, because the 8 is going to be, disposed of, because we know that the result of integer division is always an integer. So this is what is happening here. So here we have a 0. Now, what type is result? Well, result is of type float. So what C is going to do is that it is going to convert the result, the result of this integer division here into a floating point number. Because our number was 0, to make it a floating point number, C is going to add the 0000. So this is implicit conversion. So C does it. We've converted integer. We've converted an integer value into a floating point, into a real number, or a floating point value. Now we can tell C to do the correct thing instead of performing an integer division here to perform a to perform the correct division here. We can try to force C to do that by performing what is known as explicit conversion. So we're going to throw in our float here so that we can force C to treat this division as a as a division between two real numbers, such that it gives us the correct result. So because we want to convert to float or real number to a float or a real number, we specify that we have to write our parentheses, and then inside we have the float, right? And then when we save this program, let's see whether we're going to get the correct result. So we compile our program with C99. It doesn't matter, works fine for me, and I like it. So we have we print out our and check it out. We have the correct result, that is 0.8000. Of course, we can get rid of the extra zeros by specifying that we want a certain number of decimal places to be printed out. So let's say we want we want only the first decimal place. So we're going to say 0.1 for the first decimal place. So we save. That is going to take care of the extra zeros that we have there, and we compile our program. Everything works perfectly, and boom, we get the expected result, 0.8. So what we've done is we've forced C to do the correct thing. So minus this, if I omit this, C is going to treat this division as integer division, and the result is going to be an integer, which is 0 in this case. The decimal place, the 0 point is this is going to be integer division, and what is going to be the result is 0, all right, and not 0.8. So when C sees this result variable, its type is going to be what? Float. So this is going to be implicitly converted into a float. So we're going to have 0.0000. So for us to be able to have the correct result, we need to force C to to perform to divide number 1 by number 2 and treat these numbers as real numbers. So we have to force that, and we're going to throw in our float right there. Now that looks good, and that is what is going to produce the correct result. So I hope you understand the difference between implicit and explicit conversion, right, between data types. Now let me give you one more example of explicit and implicit conversion, and why it matters, the data, the conversion that why it matters that you take into account the data types that you're dealing with. So let's say, for example, I have a float. If I have a float, let's say float, let me just say float number is going to be equal to 3.56, like so. Float number is going to be equal to 3.56, and then let me declare an int, and then let me just say int number 2, for example, and then let this, I want to convert I want to convert this number. I want to convert the first number. I want to convert number 1. Let me just call it number 1. I want to convert number 1 into an integer. So I'm going to force here. I'm going to perform explicit conversion. So I'm going to say int in the parentheses, and then I'm going to, what do I want to convert into an int? So it is number 1, which is initially declared as a float, right? So now if I clear, let's now try to print out our lovely number 2. So we get our most precious printf function. Then we at least provide 2 arguments, so we can be a little bit descriptive and say the result is, and we throw in that conversion specification, right? So that is the percentage %d, and then number 2, because that is what we want to print out. What do you think is going to be the output of this particular program? Are we still going to see 3.56, or are we going to see something else? Now let's see what is going to happen. So we compile our program with C99. Hopefully we get no errors. Okay, no errors, that is good. We try to run our program. Oh, we've recompiled. Well, still a good thing. not a very bad thing to do. Look, we get 3, but initially we had 3.56. So we've explicitly told C to convert number 1 into an int. So the fractional part is basically going to be eliminated. The fractional part is going to be gotten rid of. The fractional part. We're not going to have the fractional part because we have an int. So what we have here is data loss, right? So you have to be very, very careful whenever you're doing your conversions, right? Whenever you're doing your conversions. Another example that I can give you guys is that of let's say we have a character variable. Remember that with a character variable, we can store single characters. For example, the first letter of someone's name. So we can say first letter, like so. Then we can set this equal to A as someone's the first letter of someone's name. Now let's say I declare an integer variable. Let's say number, for example, and I want to convert this first letter into an int. So I need to use int here. I need to say int here. Then I'm going to say first letter because that is I want to convert my first letter into what? Into an integer variable. So we force things here and say int, right? That is understood and that looks good. Now, what do you think number is going to be? Is number going to be an A? Well, let's see what is going to happen here. Whether we're going to get our A or we're going to get something else. We compare with C99. Pretty excited. Nice. And we print out our, we try to give ourselves, check it out. We get 65. Well, we had an A, but how can we get 65? So what C is trying to do here, C is trying to use ASCII. Now in the ASCII table, uppercase A is going to be mapped to the integer 65, right? In the ASCII table, A maps to the integer 65. Now I can also throw in another number to show you that I'm not messing with you guys. I can throw in the lowercase a, and let's see what is going to happen. So C is very clever. It's doing all the hard work, and we are doing all the easy work, right? So you see how simple C is and why it is taught as an introductory programming language in most of these universities, right? So in the ASCII table, lowercase a is basically mapped to 97. Now you can open up your favorite web browser and Google ASCII, for example, or maybe search or Bing ASCII if you're using Bing. So ASCII or Google, you search for ASCII, and then you're going to get a table basically, and then try to check and try to find out or try to verify whether A is going to be mapped to 65 and whether uppercase A is going to be mapped to 65 and whether lowercase a is going to be mapped to 97. So between if you are converting from a character to an int and you have a character in there, let me just throw in another character, because maybe you might think that we're just talking about letters and all that. Let me just throw in maybe a /. Whoa. Let's throw in a backslash, for example. Let's try to throw in our backslash, and let's try to see what is going to happen. And what did we do wrong here? C is not happy. Let's throw in our percentage symbol. All right, C is now happy. Of course, any character that you want. I just want to illustrate 1 point to you guys. Now, of course, we can also think about changing the name of this variable, because it is no longer the first letter of someone's name is now a random character. Now that is not a problem. We know what is happening under the hood, so we compile our program. Pretty excited about this. Are you guys as excited as I am when I'm trying to compile these programs? Because we're not getting any errors. We are superheroes. So we basically print out that. Boom, we get 37. Now in the that very, very special table, we have that the percentage symbol is going to be mapped to 37. So we always have to take into account these differences that we have here. So always have this in mind. So you basically have to consider a case where you can have data loss whenever you're converting from maybe a double or a float to an integer, because a float is going to hold a real number, and if you want to convert a float to an integer, you're going to lose you're going to lose data, because the fractional part is going to be excluded, right? The decimal part is going to be excluded. So always have that in mind. And whenever you're converting between signed and unsigned, signed and unsigned data types, you basically have to make sure that you know the range, and always be careful, because signed data types are going to hold both positive and negative values as well as 0, whereas unsigned types are going to hold only positive numbers and 0.